So we discuss about next topic, the magnetic lines of force due to a straight conductor. Due to a straight conductor. మన పబ్లిక్ పాయింట్ ఆఫ్ వ్యూలో ఇంపార్టెంట్ కాకపోయినా ఈ టాపిక్ నెక్స్ట్ టాపిక్స్ అర్థమైతే ఈజీగా వచ్చేస్తుంది. సపోజ్ కన్సిడర్ దిస్ ఈజ్ ఏ ప్లేన్ షీట్. Consider this is a plane sheet. If a conductor which is passes through the plane sheet like this, let a wire which is passes through the plane sheet like this, passes through the plane sheet. This is the wire. This is the wire. Consider a wire which is passes through the plane sheet, and iron fillings are spreaded over the plane sheet. Iron fillings are spreaded over the plane sheet. So now this is the wire which carries the current I. మనం ఒక ప్లేన్ షీట్ తీసుకున్నాం, ఇందులో నుంచి కరెంట్ పాస్ అవుతుంది. కరెంట్ పాస్ అవడానికి వైర్ తీసుకున్నాం. సో ద వైర్ విచ్ ఈజ్ పాసెస్ త్రూ ద ప్లేన్ షీట్. ఈ ప్లేన్ షీట్లో నుంచి వైర్ ఇలా పాస్ అవుతుంది, దీంట్లో నుంచి కరెంట్ పాస్ అవుతుంది. సింపుల్, ఈ వైర్ కరెంట్ కనెక్ట్ చేస్తున్నాం, బ్యాటరీని కనెక్ట్ చేస్తే కరెంట్ పాస్ అవుతుంది. సో దీనిపైన అక్కడక్కడ ఐరన్ చిన్న చిన్న పీసెస్, ఐరన్ ఫిల్లింగ్స్, ఐరన్ పీసెస్, చిన్న వెరీ వెరీ స్మాల్ పార్టికల్స్ అక్కడ వేసేసాం. సో ఇప్పుడు ఏం చేస్తున్నామంటే మనం, now this plane sheet is tapping like this, tapping. So after some time, a pen, by using a pen tapping the sheet, then the iron fillings are formed. These iron fillings are formed concentric circles. These iron fillings are formed concentric circles. Simple. This is a plane sheet. If a wire which is passes through the plane sheet, on the plane sheet the iron fillings are spreaded. By using a pen tapping the plane sheet, now the iron fillings are symmetrical. That means they are formed concentric circles. They are concentric circle. This is like concentric circle. So this is the conductor which is passes through it. This is the current passes through it, and these are concentric circles. So these concentric circles are perpendicular to the current. These concentric circles are perpendicular to the current. Simple. So finally we concluded that the current and the magnetic fields are always perpendicular to each other. This is the magnetic lines of force due to the straight conductor. Next, simple. Maxwell's cork screw rule. Maxwell's cork screw rule. General simple, మనం డైలీ లైఫ్లో అబ్జర్వ్ చేస్తుంటాం. The screws and the nails are easily driven into the wooden boards by using a screwdriver. ఒక స్క్రూ తీసుకున్నాం, ఆ స్క్రూ డ్రైవర్ యూజ్ చేసుకున్నాం. స్క్రూ డ్రైవర్ యూజ్ చేస్తూ స్క్రూ రొటేట్ అవుతూ లోపలికి వెళ్తుంది, లేకపోతే రొటేట్ అవుతూ బయటికి వచ్చేస్తుంది. కన్సిడర్ ఏ స్క్రూ డ్రైవర్ ఆర్ let a screw. So this is the screw. This is also having circles. Circles. Suppose now the screw is screwed by using a driver. Now the screw moving downward direction in the wooden board. It is moving downward in the wooden board. This downward direction, the screw moving direction represents the current. The screws are driven into the wooden board by using a screwdriver. The moving direction of the screw represents the current. The head of this is the head of the screw represents the direction of the magnetic field. The head of the screw this is the direction of the current which is moving downward or which is moving upward. But this is the head of the screw. The head of the screw represents the direction of the magnetic field. Simply, this is the direction of the magnetic field. This is the direction of the current. This is the direction of the current. This is the direction of the magnetic field. So simple, this is also represents concentric circles. So the concentric circles always perpendicular to the direction of the current. So the motion of the screw represents direction of the current here. The rotation of the head represents the direction of the magnetic field. Both are perpendicular to each other. This is Maxwell's cork screw rule. Next, suppose Ampere's right hand rule or right hand grip rule, grip or thumb rule, రైట్ హ్యాండ్ గ్రిప్ రూల్ ఆర్ థంబ్ రూల్. ఈ రూల్స్ అన్నీ కొంచెం కన్ఫ్యూజన్గా ఉంటాయి. అండ్ ఫైనల్గా మనకు కరెంటు మ్యాగ్నెటిక్ ఫీల్డ్ రెండు పర్పెండిక్యులర్గా ఉంటాయి. చూడండి సింపుల్ దిస్. ఇప్పుడు నేను మ్యాగ్నెట్ సపోజ్ పెన్నుని ఇలా హోల్డ్ చేశాను, ఇలా హోల్డ్ చేశాను. చూడండి దిస్ రిప్రజెంట్స్ ద హోల్డ్ చేసే పెన్నుని. సో టు హోల్డ్ ఎ పెన్ with my hand. So this thumb represents direction of the current. This thumb represents, for example, this thumb represents direction of the current. The remaining fingers, curling fingers, represents the direction of the magnetic field. So in this, the thumb represents, this is the thumb, for example. So the curling fingers represents the direction of the, so this is simple. So this, in this right hand thumb rule, right hand, this is the right hand thumb rule. So the right hand thumb rule that represents simply the thumb represents the current. The remaining curling fingers represents magnetic field. Both are perpendicular to each other. Simple. Always. So this is to hold a pen like this direction. This direction represents the current. So the remaining fingers represents the magnetic field. This is concentric circle. So this represents the current. Both are perpendicular to each other. Perpendicular to each other. This is Ampere's right hand thumb rule or grip rule. Next we discuss about magnetic lines. What is magnetic lines? Magnetic lines are imaginary lines. But what is the properties? What is magnetic field? What is magnetic flux? What is magnetic flux density? What is force on the charge? What is force on the conductor? So later we discuss about those topics. next video.